Today, we're talking about an element you think you know, but it secretly connects the entire universe, some of the weirdest science imaginable, and, well, our entire technological future. We are talking about helium.
So let's just dive right in, because this question right here, this is our whole journey today. We're going to connect that floating party favor all the way to the nuclear furnaces inside stars, and then bring it right back to the life-saving machines in our hospitals. It's going to be a wild ride.
All right, first things first. Let's start with something we've all seen, right? A balloon, straining on its string, trying to get away. Why does it do that? The answer seems really simple, but trust me, it's the key to everything else we're going to talk about. It really just comes down to weight. I mean, it's that simple. The air all around us has an average weight of about 29. Helium, its atomic weight is just 4. That's not just a little lighter, it's over 7 times lighter than the air it's pushing out of the way. So of course it floats. It's basic physics, but this one little fact, its extreme lightness, has some pretty profound consequences.
And here's where the story takes its first big, unexpected twist. You see, we didn't find helium on Earth first. Nope. To find it, we had to look 93 million miles away and stare directly at the sun.
The story of how we found it is just incredible. Back in 1868, during a solar eclipse, some astronomers saw this weird yellow line in the sun's light that didn't match anything they'd ever seen before. So they just went for it, declared they'd found a brand new element, and named it helium, after Helios, the Greek sun god. And for almost 30 years, everyone just believed it only existed in the sun. Until finally, someone found it trapped in a rock right here on Earth.
So how does the sun make it? Well, it's basically a giant fusion reactor. Deep in its core, under unimaginable pressure and heat, it's constantly smashing hydrogen atoms together to make helium. And that process, that's what releases all the energy we see as sunlight. So really, helium is kind of like the cosmic ash from the single most important reaction in the entire universe, the one that powers our sun and makes all life on Earth possible.
Okay, so if stars are making all this helium, how in the world did it get trapped inside rocks here on Earth? Well, turns out our planet has its own way of making helium. It's just much slower. It's a process that's been quietly happening for eons.
It's a process called alpha decay. Deep down in the Earth's crust, you've got these heavy radioactive elements like uranium and thorium, and they're slowly falling apart. And as they decay, they spit out this little thing called an alpha particle. And guess what an alpha particle is? It's just the nucleus of a helium atom. That's it.
I mean, just stop and think about that time scale for a second. The helium we use for our balloons and our MRIs wasn't made in a star yesterday. No, it's the result of radioactive decay that's been happening inside our planet for billions of years, slowly building up in these little underground pockets.
So where do we actually find this ancient gas? Well, it gets trapped alongside natural gas, so we have to drill for it. But it only really gathers in a few places on the globe. We are literally mining a geological savings account that took billions of years to fill.
All right, now I need you to hang on, because this is where things get really weird. Because when you take this ancient cosmic element and you get it unbelievably cold, it just kind of stops obeying the normal rules of physics. It enters a whole new state of matter.
Just how cold are we talking? We're talking negative 269 degrees Celsius. I mean, that is just a whisper away from absolute zero, the coldest temperature that can possibly exist in the universe. At that point, helium finally becomes a liquid. But if you cool it down just a tiny bit more, something absolutely magical happens.
It becomes a superfluid. Now what is that? It's a state of matter with zero viscosity. Think about that for a second. A liquid that can flow with absolutely no friction at all. It's more perfect than a vacuum.
A superfluid can do things that seem completely impossible. It can literally climb up the walls of its own container and just flow right over the edge, as if gravity doesn't apply. It conducts heat so perfectly it doesn't even boil, it just vanishes. I mean, none of it makes intuitive sense.
This is my absolute favorite way to think about it. At these ridiculously cold temperatures, all the weird, spooky rules of the quantum world, the stuff that's normally hidden away at the atomic level, suddenly become visible at a scale we can actually see. You are literally watching quantum mechanics happen with your own eyes. So that's all some mind-bending science for sure. But why does any of it matter? Well, it turns out these truly bizarre properties make helium absolutely 100% irreplaceable for some of the most critical technologies we depend on every single day.
So where is all this helium actually going?
Come on, forget the party store. Party balloons account for less than 10% of what we use. The real heavy hitters are high-tech manufacturing and, maybe most importantly, our hospitals.
A single MRI machine. You know, the thing that gives doctors those incredibly detailed pictures of our insides without any radiation. It needs over 1,500 liters of liquid helium just to keep its powerful magnets cool enough to work. So, no helium, no MRIs. It's really that simple.
And what about the device you're watching this on right now? Your phone, your computer? Yep. Making the tiny silicon chips inside them is an incredibly delicate process, and it requires helium for cooling, for creating super clean environments, and for finding tiny leaks. Our entire digital world is built with helium.
And this brings us to the final and most critical part of this whole story. We have this amazing, irreplaceable element, but we have one very, very big problem. Once we use it, once we let it out of the container, it's gone, for good.
And here is the cruel, cruel irony. The very same thing that makes a balloon float, its incredible lightness, is also its fatal flaw. Helium atoms are so light, so tiny, that our planet's gravity just isn't strong enough to hold on to them. When you release helium, it floats up to the top of the atmosphere and just keeps on going, drifting off into space forever.
So this is the bottom line. We are using a resource that is finite, that is non-renewable, and that literally escapes the planet when we're done with it. For decades, bad government policies kept the price artificially low, which basically encouraged us to waste it. The only path forward now is to conserve, to recycle, and to start treating this precious element like what it actually is, a rare and limited resource.
And that really leaves us with this final thought. From the fiery heart of a star to a pocket of gas trapped deep within the Earth, helium is a cosmic inheritance. It took our planet billions of years to save it up for us, and we're spending it all in just a few decades. So the question we really have to ask ourselves is, what happens when it's all gone?